What's going on, guys? Welcome back to TryHackMe. So after a long while, we are back to TryHackMe machines. So basically today I'm going to start with Opacity, which is also a recent room released in the site. So this is a typical ideal boot to root machine made for pen testers and cybersecurity enthusiasts. So basically here you're going to start with the enumeration all the way till you get the root access. So we have two flags to retrieve or to fetch. The first one is the local and the other one is the proof. Okay, so let's get started. Alright, so the first thing I did, guys, is all the time, as usual, the Nmap scan. Nmap scan starts with using the -A switch. This is the most noisy scan you can perform against any target. But basically it retrieves it's a detailed scan where you maximize the chances of retrieving all the information about the target. So the IP address, and here we have the available open ports 22, 80, and 139.445. So it looks like we have a Samba server running here. And also you have 80 and 22. The main playground will be over port 80. Okay, so we open the website here and I'm going to stop this, right? And so basically the first thing that you will do is to navigate to the main page. You will get redirected to login. Here you have the option to enter username and password. So it's kind of distracting actually to see a login form here, because you will start wondering what you're going to do with this login form. Are you going to test a couple SQL injection payloads, or are you going to use brute force attacks, or are you going to try your hand with cross-site scripting? So basically whenever we see a login form, multiple scenarios jump to the mind. So basically but in this scenario here we're going to totally ignore the login form. So what we're going to do here, we're going to start enumerating the site. So mainly we're going to enumerate the web server for hidden directories. So what I did here, GoBuster, use directory, okay, and this is the URL we specify, and the word list. The word list is directory list 2.3 medium. That's the word list we used. It's the easy scenario, guys. It's not that long. So once you run this, you will see two directories pop up. CSS, we're not going to do anything with this, and /cloud. So if you navigate to /cloud, let's navigate to /cloud, and there you go. So this is an interface where you can upload files, but the way to upload the files here is through using an external URL. So basically here you will put the URL to the file which you would like to upload to the web server and click on upload image. So it's not typical upload by browsing through the file system. You have to enter the complete URL to the file. Okay, that's the perfect chance for uploading a reverse shell. So what we do here, scrolling down, as you can see, we use Pentest Monkey reverse shell. You know it, guys, right? Let me again display the contents for this shell for those who are new. So cat shell. So this is the contents of the reverse shell. Okay, as you can see, it's owned by Pentest Monkey. You can grab a copy of this shell by going to Pentest Monkey or by writing Pentest Monkey on Google and then followed by reverse shell. You will find the reverse shell there and you can download it. Okay, so what we need to do here, we need to edit the IP variable and the port variable. So we put the IP address of the machine, our machine, your machine, and the port that you would like to use by the listener. So basically you can find your IP address again by using ifconfig. So use ifconfig on your machine to bring up the list of interfaces running on your machine. If you are using TryHackMe OpenVPN, make sure to locate TUN0, and there you can see the IP address of the machine that you're supposed to use. So basically we put the IP address here and of the port. The port is preferential, you can use the port you prefer. So me, I use 4545. Okay, so after we decide what kind of shell we want to use, we should now build the URL. Okay, so the URL will be the URL of the machine from which the file will be retrieved and then uploaded to the target machine. So basically the file will be hosted on my machine. So what I'm going to do, I'm going to start a web server on my machine using Python 3-m hey http.server. Okay, now this way we start a web server on my machine and take a note of the port that the web server is running on. So basically you're going to say this one. So this is the IP address of my machine. This is the port my web server is running on, and then we come to the file name. So initially, guys, you're going to use the original file name. So in my case, it is shell.php. Okay, but if you try to upload this file, okay, it's going to complain that this is not an image file. The web server is expecting an image file. So what you have to do, you have to apply file filtering maneuvers. So basically there is a file filter running behind. It is actually filtering all files that do not end with an image extension. So because this is a PHP file, it's going to be rejected. So we have to make this file looks like an image file to the web server so that it accepts the upload process. So what I did, there are multiple methods to change the extension of the file. So what I did basically, I put a pound character here, as you can see, right? And then followed by any arbitrary name .png. So some of you might be asking, why didn't we use shell.php and then .png? This is also a valid method to bypass filters, but for this scenario, it's not going to work. So what we have to do is to use the pound character. The pound character will be will be ignored by the web server when you upload the file. So the web server will think that this is an actual image file because it ends with .png. That's how file filters work, file extension filters. They look at the end of the file after the final dot. Okay, if it includes an acceptable format, it's going to let it pass. So because we use an acceptable format, it's gonna be passed, right? But what about the pound character? The pound character will make the web server, upon execution of the file, ignore everything that comes after this. When we execute the file, of course, not when we upload it. Okay. After the upload process, you want to execute the file. So upon execution, everything after the pound will be ignored. And hence, shell.php will be executed. Okay, so what we did, we made a copy of shell.php, the original file, and created another name for it. This is the new name. Now this is the name that will be used when we build the URL. So back here, as you can see, shell.php pound a.png. Going back here, don't forget that the web server is running and waiting for the request to come. And one additional thing, guys, don't delete the original file. Notice that when I made the call here, when you click on upload, a call will be made to the web server. And all of these are not valid calls. I'm talking about these. So the first call, as you can see, was made to shell.php and it wasn't found. And another call was made to shell.php and it gave a valid response. So what happened here? The first call, okay, was made to retrieve this file, shell.php pound a.png. So when I click on upload, it's going to look for this file, right? It's going to get uploaded. Now the next step is to trigger the shell. So I have a listener running here on 4545, right? So after I upload the file, we need to trigger the shell. So basically, as you can see here, this is what happened when you successfully upload the file. It's going to tell you this is the image link to access the file. So you're going to take this one, open a new tab and navigate, but you have to remove everything after the pound character because it's going to be ignored, and you will navigate to this file. Once you navigate to this file, as you can see, it's going to be retrieved again from your web server, and the call will be made, and you will catch the shell. Okay, so don't forget, use this one to upload the file and keep the original one in the same directory where the web server is running, because it's going to be retrieved and run. Okay, now we received the shell. We use a stabilizer to stabilize the shell. As you can see, we land as the web server directory, web server user. We are under home, and we have sysadmin as a valid user with a home directory. Now we list the contents of the sysadmin directory. We see we have two files, one file, local.txt, and another directory named scripts. If we try to display the contents of the local file, local.txt, we get permission denied. So upon inspecting the permissions of the directory, we see that we don't have permissions to view the local file. As you can see, sysadmin, the owner, can read and write, and the group is also sysadmin. And since the web server user is not part of the group, they cannot view, write, neither modify on the file. As you can see, the group permissions are cancelled or none. Okay, if we go to /opt, and again guys, I get asked all the time, how do you know it's under opt? How do you know? You have to search. I'm just giving you the nutshell here. So basically under opt, we have a file called dataset, and the extension is kdbx, which is the file extension used by a password manager called KeePass. Okay, so what we're going to do, we're going to retrieve this file. So to retrieve this file, this time we have to run a web server on the target machine. So use Python, okay, and we make a note of the port that's used by the web server. To retrieve the file, we have to go to the machine, the attacker machine, retrieve the file using wget. We put here the IP address of the target machine, the port that the web server is running on, and specify the name of the file that we want to retrieve. And here we specify the directory which will host which will store the file, and the name of the file. As you can see, we received the file. Now it is kdbx. So to crack the file, so kdbx is the file extension used for KeePass. So KeePass, this is KeePass, okay. Now KeePass is a password manager, and if you have entries or passwords stored in a KeePass database file, it's going to ask you for the master password when you first open it. So to find the master password, we have to crack the password or find it. This is the file, okay. So to crack the master password, we have to convert this first into a hash. So we use the available tool in Kali, which is KeePass to John. We put in the file name and then a row which indicates that we want to redirect the output to a file called dbhash. dbhash is the file that contains the hash. Now after we converted the database into a hash file, now it's time to crack the hash and convert it into a plain text password. Again, we use John the Ripper. We specify the word list. The word list that will work in this scenario is raw_q.txt, and we specify the file that contains the hash. In under 2 minutes, or actually not 2 minutes, less than 2 minutes, in under 30 seconds, you will have the file, you will have the hash cracked, and this is the password. This is the password for the master file. Now you will go ahead and open the file with KeePass, provide the password, and this is what you will receive. User password sysadmin, and inside the sysadmin you have a password here. You can click on edit entry, and you will see the actual password for the sysadmin user. What you're going to do, you're going to remember that there is an SSH running on the machine, so we will use the sysadmin username along with the password to log in. So now we log in as SSH, which is way more stable. We inspect the ID of the user, we are sysadmin, and we display the contents of the local.txt file. This is the file. Alright, previously we saw that there is a directory named scripts. So we decide to take a look at the contents. We have library, directory, and script.php. So we got curious enough to uncover the contents of the script file. Let's take a look here. So we have a comment here saying that backup of scripts sysadmin folder. So required once. So it is actually kind of retrieving the help of this file under this directory to create a zip file. So using zip data here, the function, to create an archive of this directory and store the contents or the final backup file under var backups. So it is actually creating backup of this directory and storing the archive under this directory, var backups. That's the first function of this file. The other function is file scheduled removal. So dir equal var html cloud images. So it's actually deleting the contents of the images file. Notes that the images directory is under the root web server directory var html cloud images. So all the contents under this directory it's actually being deleted every X minutes. We don't know yet. So backing up scripts directory and deleting the contents of the images directory. That's what it's actually doing. So given that this file is running on a continuous interval, what we can do here, we can hijack the file and make it connect to my machine, i.e. creating a reversal out of this file. But first we have to inspect the permissions of this file. So let's inspect the permissions of this file. ls-la, not here, ls-la scripts. We see that the script file we inspected earlier, the owner of which is the root user and the group ownership is under sysadmin, which means we can only read the file, we cannot modify it. So all hopes to convert this file into a Trojan horse are actually they're all like in vain. We cannot do this, we cannot do anything with this file. They fade away. All the hopes fade away if you want to use this file as a reversal. So we turn the attention into something else. Let's get back to the contents of the scripts file. See this file. So it's opening first a file called backup inc under library directory. So if we're able to modify this file, we can still manipulate the workings of the script.php without even modifying it. So what we need to do, we have to make sure that sysadmin can modify backup. So let's inspect the permissions. Alright, ls-la, and we see that this is the file, and again we cannot do anything with this file. It's owned by root and the group is root. So it looks like it's mission impossible, but don't forget that if we inspect here, let's go back. If we inspect again the permissions on the scripts directory, as you can see, the library directory, which contains the backup PHP file, contains some hope for us. So as you can see, the library directory is owned by sysadmin. So sysadmin can create files inside library directory. As you can see, it's the owner and the permissions are read, write, and execute. So what's going to happen here is we can create files inside library directory, create files, modify, and delete files. So what if we delete the original file, this one, and we create our own file, right? No need to modify any existing file because we cannot do that. We have to create files. So what I did here is I copied the backup file into the home directory of sysadmin. Okay, so I made a copy of this file to the home directory of sysadmin to be able to play with it. Okay, so let me show you guys what I did. So nano backup. So this is the original file, right? I added these two lines. These two lines will connect to my machine. So I created a listener here on port 4546, and I put these two lines. This is actually a one-liner PHP reversal. Okay, this will connect to my machine. All right, let's go back now to the scripts.php. So first, when it requires or when it makes a call to the file here backup, don't forget that after we modify the file, it will make a call to my machine here. Okay, so after we created actually a new version of the file under the home directory of sysadmin, we remove here the original file under scripts directory and copy the version we created to be under scripts library. So why we can do that? Because the library directory holds the permissions where we can read, write, and execute by the sysadmin. Since the scripts file here, where is it? The original file here, which is script.php, runs on a periodic basis. It's going to connect to my machine now on port 4546 as specified, and it's going to be as root because the file is running as root, and this is how you get the root access, or this is how you get the root flag. So that was it, guys. I hope you enjoyed that, and I will see you later.